Scientists predict that in about 5 billion years our Sun will exhaust its hydrogen fuel and begin its transformation into a red giant. This process will cause the Sun to expand massively, possibly reaching as far as Earth's current orbit. As it grows, it will first scorch the inner planets like Mercury and Venus. Earth's oceans will boil away, the atmosphere will be stripped, and all life will cease to exist. Eventually, the Sun may engulf Earth entirely. Even if Earth somehow escapes total consumption, the extreme heat and radiation will render the planet completely uninhabitable. This scenario isn't sudden. It will occur over millions of years, but it is an inevitable consequence of stellar evolution. Scientists use models of stellar life cycles to predict these changes, and this transformation marks a natural end to the Earth's ability to support life. The red giant phase will eventually end, and the Sun will collapse into a white dwarf. But by then, the solar system as we know it will have drastically changed. This scenario highlights the importance of space exploration and the potential long-term need for humanity to find a new planetary home. One of the most catastrophic but plausible scenarios for Earth's end is a collision with a large asteroid. Though rare, such an event has happened before, the most famous being the asteroid that caused the extinction of the dinosaurs 66 million years ago. A similar impact today could destroy cities, trigger massive wildfires, cause climate disruption, and lead to a collapse of ecosystems. Scientists track thousands of near-Earth objects (NEOs) through programs like NASA's Planetary Defense Coordination Office. While most detected asteroids pose no immediate threat, even a small miscalculation could be disastrous. An asteroid only a few kilometers wide, if on a collision course with Earth, could release energy equivalent to millions of nuclear bombs. This global devastation would block sunlight, drastically lower temperatures, and disrupt food chains, causing mass extinctions. Governments and space agencies have considered planetary defense strategies, such as deflection missions using spacecraft or nuclear devices. In 2022, NASA's DART mission successfully changed the orbit of an asteroid, proving such methods are technically possible. Still, early detection and global coordination would be essential to prevent an extinction-level event. Climate change is a slow-moving but highly destructive force that could gradually render Earth uninhabitable. Driven by human activities such as burning fossil fuels and deforestation, greenhouse gases like carbon dioxide trap heat in the atmosphere. This has led to global temperature rises, melting ice caps, rising sea levels, and extreme weather events. Entire ecosystems are being pushed to the brink, and many species face extinction. If temperatures continue to rise, certain areas of the planet could become too hot for humans to survive. Coastal cities might be submerged, and agricultural systems could collapse due to droughts, floods, or changing precipitation patterns. Climate change also increases the likelihood of resource conflicts, mass migrations, and economic instability. While the Earth itself will survive, the conditions needed for complex life, especially human civilization, may not. Efforts like the Paris Agreement aim to limit global warming to below 1.5 degrees Celsius, but global cooperation, innovation, and behavioral change are essential. If ignored, climate change could be the slow apocalypse that eventually drives humanity to extinction or forces us to find new ways to live, perhaps even on other planets. Earth's ecosystems are complex webs of interactions between living organisms and their environments. Each species plays a specific role, and even small disturbances can have cascading effects. Human actions like overfishing, deforestation, pollution, and climate change have caused serious disruptions to these systems. Coral reefs are dying, rainforests are shrinking, and biodiversity is plummeting. When key species disappear, it can destabilize entire ecosystems. For example, the loss of pollinators like bees threatens global food supplies. If too many of these systems collapse, humanity may lose access to essential resources like clean water, air, and food. The decline in ecosystem services could lead to mass starvation, disease outbreaks, and social unrest. Ecosystem collapse doesn't need to be total to be devastating. It can be gradual, region-specific, and often irreversible. Efforts to combat this include conservation programs, sustainable agriculture, and biodiversity protection laws. However, time is running out. Scientists warn that we are approaching tipping points beyond which recovery is impossible. The collapse of Earth's ecosystems could be one of the most immediate and irreversible threats to human survival, if not addressed swiftly and globally. Beyond Earth, the ultimate fate of everything lies in the cosmos. Scientists have proposed several theories about how the universe might end, based on current observations and models in cosmology. One leading hypothesis is the Big Freeze, also known as heat death, where the universe continues expanding until all stars burn out, matter decays, and temperatures approach absolute zero. In this cold, dark void, no energy or life can exist. Another theory is the Big Crunch, in which the universe's expansion reverses and everything collapses back into a singular point, possibly triggering a new Big Bang. Alternatively, the Big Rip suggests that dark energy could one day tear apart galaxies, stars, planets, and eventually atoms themselves. These cosmic doomsday scenarios won't occur for billions or even trillions of years, but they highlight the impermanence of all things, even the universe itself. While we may never witness these events, understanding them helps scientists grasp the laws of nature, the origin of time and space, and humanity's fleeting place in the cosmic timeline. The end of the universe reminds us of how extraordinary and fragile our existence truly is.